So what we're going to show today is the Tritium Trust wallet running, the new wallet running over Lisp, and how we've packaged the daemon and the Lispers.net code. So let's go to the one architectural slide, this one right here. This was from my presentation at the conference. Basically, what we're trying to show you architecturally is that when Nexus runs at the application layer, it could send to regular IP addresses. When it makes TCP connections, it could send to regular IP addresses. That's the side that shows you it's just sending to RLOCs. We call them RLOCs, but they're just regular addresses when Lisp is not involved, because those addresses are routable on the internet, which allows Nexus to be able to establish connections anywhere. So the Nexus doesn't have to change to use Lisp using EIDs versus RLOCs. It all depends on where it sends. And we're going to show you in this demo that it can send directly from an address that is called an RLOC to somewhere out on an unmodified Nexus Tritium Trust not running Lisp, okay? And then it could also send by sourcing from EIDs right here and send over Lisp. So Lisp is kind of a sublayer of the network layer, and the reason it's used, and we put it at the top of this layer 3 IP layer, is because when packets are sourced by EIDs, Lisp gets involved, does a mapping of the destination EID or not to an RLOC. If the destination's an EID, it will be found in the mapping system and mapped to an RLOC. And then Lisp will then put a new header on and then encapsulate to an RLOC, which is routable. So we call EIDs mappable addresses and RLOCs routable addresses. And we kind of use this route in the kernel to define when a source EID should use. So if the Nexus code is going to send to anything that begins with 240, it'll be sourced as an EID. If it's going to send by not to a 240 address, it'll just send it directly. But what we want to also show in this demo is that we are able to talk to non-Lisp devices. Okay, so what happens is we want a Nexus node here to be able to source to an EID and talk to an address that's not running Lisp. Okay, so let me show you the overview, what we're trying to do right here. Okay, so what we have going here is we want there's actually 3 components that are running on my laptop right now: the wallet application itself, and the Nexus daemon, and the Lispers.net Lisp layer. Okay, if you look at this right here, you'll see all this stuff running. Let's see if I can put this in the background. Let's see, let me just do that. Okay. So what I'm showing on this display, and we'll refer to it, here's the wallet app running. It has 14 connections right now. This down here is running the Nexus code and the Lispers.net code. Okay, we'll show you how that's going. I just have this. This is the NX orbital scan, just to show you that we are going to stay synced with the block height. So we see it's 2.3, 60,000. We see 2.3, 60,000 here. We'll get back to this in a second. Okay. So what we're trying to show you is we want to be able to package the Nexus daemon and Lispers.net to run on Debian. So we could implement once and have it run on all kinds of different platforms. And we do that using Docker containers. The container actually is a Debian kernel, and we're running as applications on this Debian kernel in user space. And if Docker runs on Mac OS, on Windows, on Ubuntu, on Debian, or any other platform, this code will just run as is. And we'll show by doing this, we'll be able to provide a much stabler product because we're making it optimized for Debian, and we can make it scale and not have to worry about the platform idiosyncrasies. However, the wallet code has to run on the native operating system because it has to make use of the UI features and the windowing system and all this kind of stuff. So what we're showing here in this demo is that the Tritium wallet is running on Mac OS on my MacBook here, and there's a Docker container that's running with the daemon and the Lispers.NET code. Okay, and what we're going to show you is that Nexus comes up and actually creates TCP connections to all 16 Nexus peers out there. They're all over the internet. It doesn't matter where they are. We use all the logic to connect to the seed nodes first, and then the seed nodes advertise any other types of nodes that this system could connect to. Now, what's going on underneath is that all these connections that are going over Lisp, these packets are being encapsulated by the tunnel using Lisp encapsulation, by the container, I mean, and it's being encapsulated to this RTR. That stands for a recapsulating tunnel router. So it's a Lisp RTR that's sitting in a VM in Google Cloud. It's encapsulating there because we want any return packets to come from the RTR back into the container. And since I'm doing this demo at my house, there's a NAT device that's sitting right here. Actually, it's sitting right here on my Wi-Fi network. Okay, so we want the RTR to be able to pierce the NAT and send packets through it, so the applications don't have to initiate connections. So it turns out that any socket listens that Colin is doing inside the Nexus daemon can be connections could be initiated from outside coming in because it's running over the overlay. Now, if we were talking to other Lisp nodes, this guy would just encapsulate to another MacBook, for instance, or a Windows system. But what we're trying to show here is that these systems are talking to non-Lisp sites or non-Lisp EIDs. Okay, so what this RTR is doing is he's going to encapsulate to this other XTR. This XTR is sitting in as a VM in AWS. And what it's doing is it's being the exit point for the Lisp domain, so to speak. And what it does is it actually translates the source EID. Don't forget the packet is being sourced by an EID here, encapsulated. The header is being stripped off, re-encapsulated here. And when this guy strips off that header, what's inside is the 240 address. Well, a 240 address is an EID which is not routable on the capital I internet. So what this inner working system does is actually translates the source address from 240 to its IP address on this interface that is going to exit AWS, which means these guys all believe via NAT that they're making a connection to this address sitting right here. So when packets return, the XTR1 will then translate the destination address from its own Ethernet address here, its Ethernet IP address here, to the 240 address because it created state on the translation that happened on the outbound packet. So what we're able to do here is we're able to inner work, and these guys just believe that this address is a regular routable packet, where the Nexus believes it's making connections to everybody else. So let's first show that in this display. So this is the container, we call it wallet, and as I showed you before, the Nexus code is running and the Lisp code is running. Oops. And if I do a TCP Nexus, it's just a netstat that's showing you the connections that are established. If you kind of look, there's some connections that are using the local IP address on my Ethernet interface, which is natted to these external places, and then there's some 240s. If we look and see how many are egrep C240, and if we say get peer count, oops, peer count, I have some aliases I forget. Okay, so there's 16 connections, okay? And you also know that the wallet says there's 16 connections up here. Okay, so that's good. Out of the 16 connections, 9 are being used by Lisp, which means 9 are being used with this 240 address. Now, how are we doing that? Well, I have a little script that goes out and reads this netstat and basically creates host routes to each some of these using 240 as the address. And what I'm going to do now is I'm going to run the script again to see if we can go from 9 TCP connections using Lisp to all 16. Okay, so let me do that now because it takes a little while to build up. The script basically goes through this list here, and that's host routes for the ones that aren't 240. So I'll just run that real quick, right? And then what I'm going to do is I'm going to take the Nexus process down, and then I'm going to start it back up. Okay, so the Nexus process is coming up. Let's look at it again. And let's look at the TCP connections. The ones that you see in time wait, these are the old connections, right? Notice that the wallet said 0. Okay, so now what's interesting is how is the wallet talking to the daemon? Okay, so let's go talk about that while these connections build up. Let's just see if any has come in. There's still time wait. So if we come back here, we're showing that the wallet is running natively on Mac OS, and it's using the RPC mechanism to talk to the Nexus here. Just like the wallet, the Qt wallet or the Tritium wallet can talk to a daemon anywhere on the internet using the RPC mechanism, it's going to use it across this container boundary. So if this was running on Windows, this would be a Windows binary that would be running on the native platform, and then we'd have a Docker container that runs on the Windows platform, and it would behave the same way. Also, if we wanted this container to run somewhere out on the internet on a seed node or whatever, and the wallet was going to use it, it would use it the same way. And we can do this with the miner. A miner can do the same thing. Miner can use the Nexus daemon that's remote or co-located in a Docker container. We could even, when we implement the wallet on a mobile platform, it could do the same thing. So you see that there's all these combinations of how we want to maybe deploy these components in a product, but we're trying to reduce the number of combinations by using containers. Now, Docker containers are useful because they look like a separate operating system that runs, and you could actually run multiple instances. If we chose to, we could run a really high powerful seed node with, say, 10 Docker containers that are being daemons and lispers.net for 10 different remote wallets somewhere. These are the sorts of things that we can do, okay? So just to show you that that code is actually working well is that if I come here, and this window up here is Mac OS. So if I type a get info, here is the JSON that's being returned that shows you the block height. Here's the block height, 23, 60,638, pretty close to the orbital scanner, and exactly what the wallet says because it's using the same interface. Okay, this would be local in the container. If we do a get info, would be the same thing. So all the logic, all the state variables and everything are all running in the daemon, but it's accessible via command line in Mac OS, via the wallet in Mac OS, and of course inside the container as well. Okay, so let's have a look and see if we establish some connections. Okay, so not very many are coming up. We'll figure out why, but at least we're consistent. We see 3 established here. The wallet should catch up. Peer count is 3. We see it change to 3. Oh, that worked perfectly. The arcs didn't update, but that's something that we can work on. Let's keep looking. Oops. And we'll see if more connections get established. So they're right now all 240 connections, which are good. Wait for this to happen, come up a little bit. Let's see, what else can I talk about? So when we run Tritium, basically this daemon here is just going to have the Tritium stack, which means it's going to run the new protocol, it's going to have the smart contracts, it's going to run in legacy mode so old systems can talk to it. So this is kind of setting the groundwork for us to do the Tritium stuff. And that'll be, here's a sneak preview for the next meetup. We'll show you how Tritium runs, but this is just showing you another container that's running on my Mac as well. Let's go here and say, so the one that's called Nexus Dino Laptop, this is a client running the Tritium daemon talking to this seed that's sitting out here, okay? And we'll show you that later. But this is just telling you that IPv4 and IPv6 pings are working to the seed node, okay? So basically same architecture. So we're using existing stuff so we can test, and we're going to use it for the new stuff. Okay, so that's pretty much the quick demo. If you guys have questions, go ahead and write them in. Let's see if we got more connections that have come up. Ah, a lot better. And look, they're all 240s, right? So let's count them. The total number is there. Let's do a TCP Nexus egrep-c of 240. And we see 13. Okay, so 2 connections came in since I typed the commands, right? 11, no. Oh, this is a sin. I should have done this. Egrep established, egrep there. And now it'll be consisting of peer count. 12, 11. Is my grep not working very well? The reason that there's a difference is because these 2 connections here are not established yet. Okay. But the RPC says there's 12. It's the same RPC that the wallet's using, so that's good. Everything is in sync. Let me refresh this orbital scanner, 6648, 6645. So the wallet is only 3 blocks behind. Not a big deal usually. Okay, so this is interesting here. This was a new peer that was discovered since the previous incarnations of the Nexus daemon. And since I didn't have a host route to say use 240 as a source address, it's using a regular address. So it's actually showing you that this inner working is actually working, where for that one connection, we're using this path through the protocol stack, and for all the other connections, we're using this path. Okay. So I'll pause for questions. You can go ahead and shout them out or write them in. Colin, do you want to add anything?
I mean, this looks like a pretty good introduction to kind of where we're at, where we're going. Kind of one of the reasons that we want to containerize everything, showing kind of how the Tritium wallet's working with the Tritium daemons. I think it's setting the stages for kind of the next phases. So I think you did a really good job. I don't really have any additional comments. Anybody else?
So just to review real quickly, that the blue, I didn't say, I had this legend I built here, but I didn't explain it well. But the green arrow just means that the wallet is RPCing into the Docker container to get its data so it can display it in a GUI format. And then this is the data path or the encapsulation path. And these are packets that are going natively to the peers. There's no Lisp running over here. It might be kind of obvious, but I'll pause for questions now.
Yeah, and I sent one into the chat group. Sometimes people like to ask them there.
Yeah, so I just had a quick question, which I think I know the answer to, but just for everyone else's benefit. We don't have to use Docker, right? We're going to be able to pull down the code, compile it ourselves, run it natively on any OS outside of Docker, but we are just going to provide the containerized and pre-built daemon within Docker as well.
Your question was a little confusing. When you said pull down the code, you didn't say which component. So
Oh, sorry, just the Nexus daemon. So outside of Lisp, and take that out of the picture for a second, we are still going to be able to run without Lisp by pulling down the daemon code and running that natively on whatever OS we want to.
Colin will have to comment about the support of the daemon on other platforms.
The daemon is designed to be cross-platform, so we still maintain that backwards compatibility in case somebody does want to do a native compilation. But as far as Lisp, it only fair grants the Unix system. So Lisp will require at least a Unix Docker container, which is Debian-based, or you can run it on OS X or Linux native Lisp if you want to as well. The Docker container just makes it really easy to deploy and have everything already in there, because setting it up and adding wraps and everything can be a bit cumbersome. So it's kind of for a user functionality, but Windows is the one that is not too privy, doesn't really like, doesn't have very good network tools. So it doesn't really work too well on Lisp. So that's where, in order to use Lisp on Windows, you're going to need to use the Docker container.
Okay, so for most users, they're just going to use Docker, probably without even knowing it. We're just going to package this up for them. Is that fair?
Yeah, I was just going to say that. That's absolutely right. When they do the install of the wallet, it will also auto-install Docker for them. It has to be a one-click, as you've mentioned before, Paul. So we have to go that route.
It's going to be a one installation that's going to install Docker and then download the container for them, which will be pre-built, and then get it all fired up and running. So it should be, one-click install. Kind of like when you download for Google Chrome, you get kind of an online installer and it'll install the components for you.
All right, so just on that then, the use of Lisp is going to be optional, I assume. We don't have to use it.
It's going to be optional, but it's going to be set by default in order to run. There are going to be certain requirements to use it as far as having the EID and the sig chain, which is going to create kind of what we're doing with the overlay is we're making it kind of if you think of the capital I internet as kind of the insecure world where you don't know who anybody is, what we're creating is kind of a trusted layer with Lisp as the overlay and then Nexus sig chain, so you know who to communicate with and create that higher level of safety. So, I mean, you will be able to function on a regular IP address, but you're probably not going to get access to certain network features that are going to be required, basically having an EID. So we want to leave people with the possibility to enable or disable certain things, but they're going to disable a large amount of features if they disable Lisp.
So one of
the other thing I'd like to add is that if you don't run Lisp, there'll be more combinations of things that the poor user will have to deal with, like traversing NATs, making multiple interfaces work, and the multicast won't work as well. That just goes under one of what Colin just said. It'll be one of the features of Tritium that's going to depend on multicast. So by putting a lot of the functionality in the overlay, it'll make it easier for the user to get all the features that we're going to advertise.
And to kind of ascend into the trusted layer, because part of that is you need to have a unique routing identity that can't be spoofed. The RLOG space doesn't really matter, but on the overlay itself, we want to really combine that with the cryptography so that you know exactly who you're communicating with, and that's where a lot of the new security features actually start to come in. If you think of kind of the overlay as a privilege that somebody gets elevated to as they build up more reputation, otherwise they'll be kind of in the underlay access points of the network where you'll be able to still do some functions, but you won't be able to have as much those elevated privileges.
Okay, so where I was going to with this, and Dino, you and I have had a few conversations about this recently, was the use of the legacy RPC API and also the new APIs that we're going to be developing, and how integrators communicate with them. At the moment, they're by regular IP, and therefore that's why I'm asking about whether Lisp is optional, because and how we communicate with those APIs. You know, should they be by regular IP? And I was asking you, Dino, recently about whether we can go from non-Lisp to Lisp and vice versa, or whether if you have an API server that's using Lisp, does that mean you can only communicate via an EID?
No, I mean, you
yeah.
can answer that, Dino.
Okay, so let me explain to the group what that question means by an example. I think it'll be useful. So when I was sitting in this container here, if I type in my EIDs, what this is actually doing is using the Lispers.net API, which is basically curling using a RESTful interface. And when I type get info, it's using the RPC mechanism in Nexus. So what's happening here on this command line is that we're using two different APIs and two different components. What Paul is asking is if somebody wanted a single pane of glass or a single interface into Nexus that also contained Lispers.net, will they be able to get the EIDs by going through the Nexus APIs? And the answer is yes, we want to be able to have a pass-through type function. And we could under, the back end could do it multiple ways. This stuff could be made available to the daemon when it's actually starting up. But, there's things where we can show you rates and like here's some packet counts that have been moving. This is telemetry data that the Nexus daemon, the Tritium Nexus daemon is going to use to do more quality peer selection. So there's some stuff that's going to have to be periodically pulled. But yeah, Paul, we should be able to do it with one single pane of glass.
Actually, Dino, that perhaps wasn't quite my question. And if you just go back to the get info example, what happens when you do a get info is the instance of Nexus that you invoke makes an HTTP request by default to 127.0.0.1, okay, localhost. But you can type Nexus -RPC connect equals and whatever IP address you want, and then get info, and it will make that RPC call via the IP address that you type in, right? So this is a regular IP address, and that's how you're invoking our RPC. And integrators currently use that interface. They don't necessarily use the Nexus daemon to pull information from our RPC. They might do it just via an HTTP post, okay? So, but that's via regular IP address. If the RPC server is using Lisp, can you still make HTTP posts to it using the regular IP address? And more importantly, can you do it using an EID?
Lisp detects whether it's an RLOC, a regular RLOC address, or actually a Lisp based on a prefix. So the 240 address is unroutable by the capital A internet. We also have other prefixes in our IP version 6 that'll be for unique crypto IDs and unique multicast addresses, which means that Lisp detects whether it's an EID that it should be using the overlay for, or whether it should just pass it through on the underlay. So Lisp supports both the overlay and the underlay. So running Lisp does not lock you into exclusive EIDs. You can still use the RLOC space without relying on EIDs. So short answer, long answer, yes.
Yeah, that's absolutely correct. The Lispers.net code and the Nexus daemon could receive packets, make TCP connections both on the EID or the RLOC. So you can go, an old system that's not doing Lisp could use the RLOC. A new system that's on Lisp can use the EID. A new system could also use the RLOC. So all those options will be available. Don't forget the EID that's set in the container for use of Nexus can also be used for other applications, including HTTP or doing Lisp stuff itself.
And that's where you get really fun features with it, because when you're using that EID that you're also using on Nexus, another service that recognizes that EID as a Nexus-specific signature chain EID will be able to resolve that if they have a local daemon running and check the ledger and get stats and make sure that that's somebody that they've seen before, so that that's where you start to get some of the properties of IP spoof immutability, where you can't spoof an IP address, where you have another layer of identity on the actual overlay. So just going to a normal website with the EID, you're not going to have to go and log in with a different device or select this through your email saying, hey, there's a security alert, somebody's using a different IP address. Since you'll still be able to roam, you'll maintain your EID, and that EID will be what was registered in with the website associated with your signature chain when you generated the account.
Okay, so from a practical point of view, I think the practical example that I'm trying to get to is if you have your daemon running at home, for example, using Lisp, but we had our wallet UI, which talks to it via RPC. That could be running anywhere. You could be out and about, and it could be running on your laptop, or in the future, it may even be a mobile thing, or it could just be a web-based wallet that makes those remote calls to the daemon running at home. Okay, in that scenario, in order to make it secure and to do NAT reversal of your daemon running at home and all of that, it would be ideal if your Nexus daemon running at home was using Lisp. If your calling code, whatever that be, the Nexus wallet then is also using Lisp and therefore can make those RPC calls via the EID rather than needing to know the regular IP address of the daemon running back at home and therefore having to deal with the NAT reversal and stuff like that. That's the scenario I'd like to get to, and I believe the way to do that is
basically this diagram, right? This is running outside, wants to do an RPC call over the network to this Nexus daemon that's sitting behind a NAT. So
Yep.
it has to do it using an EID. And using this inner working function, we could do it.
Okay, so is that something we need to support, or something we are already supported, or what's the?
So it's supported by using by putting the inner working functionality in another pair of boxes or quad boxes. What you and I were testing is this functionality embedded in the RTR, and I had some functionality. I found some bugs associated with it. So it's a question is, do we co-locate it or not? It's a network design issue, but we can certainly support the functionality and have showed it in this demo here.
I guess the other way to do it is that the remote node, so let's call it the GUI, right? So the Nexus GUI could be using a local Nexus daemon in order to make the remote call, which is kind of what happens now when you go into your command line. You do Nexus get info. That's a local daemon that's making a remote call because you can supply a remote IP address. So presumably we could have the local daemon.
Well, hold on a sec. So this is what the get info does for Mac OS, doing exactly what you said. But inside the container, we use the Nexus command line. So if the daemon was co-located, it could use this, or it could use localhost to itself as well, right? So you weren't implying that it's required to use this, right?
Correct. I guess what I want is the local daemon to also use Lisp.
Well, if the local daemon is running right here where the UI is, it has all the blockchain state from the network, so it doesn't need to communicate to this one. The reason it would want to communicate is because the daemon wasn't running there. That's what I thought the original case was.
That's true. I meant, so I still mean, having not using curl. So having a daemon, you issue the get info to a local daemon, but you tell that local daemon to connect to a remote RPC server, which is
why does it need to do that? I don't think it supports that. So why does it need to do that?
You can, since I'm listening you can receive anything. So if the RPC server in that specific signature chain has that EID, and you know that EID from remote, let's say a mobile device, then you can do a remote RPC over the capital I internet, do the NAT traversal, which you're going to need, obviously, if it's a wallet that's running on your local computer. So that way you have an extra security, where if you have your funds that you keep at home running on a computer with an encrypted wallet, you can remote through an encrypted connection from a mobile device or a laptop in a coffee shop from the GUI over the capital I internet and access that remote daemon through the RTR.
Exactly.
And that access from the coffee shop was not running Lisp, or was?
No, it would need to be running Lisp if we're going to do NAT traversal. Generally, the current methods of like UPnP and NatPnP don't really work too well. So you would most likely need to have Lisp co-located either on the mobile device or the other device that you're running the interface from, so that the interface could essentially be connecting through Lisp, then making the EID connection to the remote.
Right.
Yeah. So yeah, that's the sort of scenario that I can see being really valuable, is where you have your wallet in one location at home on a server, and then you can take your laptop or tablet or whatever else that supports Lisp and have and can run Docker, I should say. That's the important thing. And then it has the Nexus daemon and Lispers, the Lispers.NET code running in that Docker, and you can issue a get info from a command line, but it's actually going to talk to your server at home.
It's retrieving the balance from the wallet.
Yep,
That's
exactly.
Yeah, and you never have to co-locate the wallet when you're mobile, so you never have to carry funds around you, but you still have access to your wallet just from the remote.
Yeah, Paul, I just think this instance here is just running here, just another instance of this running somewhere else, right?
Yeah.
I take this laptop with me and in a coffee shop, and those 16 connections actually stay up. As long as I don't power down, I could actually change the NAT that I connect to, and the connections stay up. That's another benefit of Lisp, is that you have this kind of session survivability, right? These connections don't go down. If I would go now and change to like my cell phone hotspot, these connections would stay up. The 240 ones would, of course, right?
As long as they have the same EID and you don't have any timeouts.
Right. That's exactly right.
Yep.
Normally they reestablish because I close my laptop, and that's the same as the timeout case, right?
Yeah. If you don't get a ping or a pong within 60 to 120 seconds,
You'll take them down, right? Use the Nexus app.
Really, you never know with TCP. If you get a broken pipe somewhere, you don't always get something back. So
Right.
timeout for just in cases.
So, Colin, and this is code that I've just not looked at yet. Have we had to do anything in the Nexus code to make our connections over Lisp?
No, so Nexus, basically the only changes we had was adding some Lisp seed nodes. And so since Lisp runs down on layer 3, Nexus is just running TCP connections like normal. And if you try to put in a 240 address, it will still try to make that TCP connection if you're not running Lisp, which other routers really won't like that because they're getting an unroutable address, so they'll just drop your packets, so you wouldn't get anything back. But when you have Lisp and it does an encapsulation of it, then that Lisp detects that 240 address is a Lisp address, and then it does the packet encapsulation so that you can make the connection through, because it's basically putting on an IP4 header on the outer side to the RLOC and then stripping that IP4 header off under, and then you get your actual packet that you're sending. So Lisp is kind of acting as that overlay that allows it to transit across, and Nexus, it's just seeming like it's connecting to another TCP connection. We can detect if it's a Lisp address in Nexus, as you know, in address.h, where we have all the different RFC detections of each different address. We just do the same thing there. If we want to have a flag in the Nexus daemon for Nexus to know it's connected to a Lisp address, which would be set by the flags we have of the certain bits that we have to flag. I think we did FE for crypto EIDs and FF for regular. I think that's exactly what we did. And then 240.
I used FEs for random addresses.
Okay.
And FD for crypto.
FD.
FF is multicast, IPv6 multicast addresses.
Yep. So we use those flags. Since he uses those flags in Lisp, we can detect if we're connecting to a Lisp address in the application layer just by that simple prefix. And he detects that, and that decides whether it uses the underlay or the overlay.
Right. Yeah, so when I joined, Paul, when I joined the project, one of my challenges or premises that I wanted to make was, let's see if I could get this application to run over Lisp without me touching a line of Nexus code. And I haven't touched a line of Nexus code in the last 8 months. And the reason that's important is because we've been saying for the last 10 years that hosts and applications don't have to change to run over Lisp. And we want to prove that true in many of the use cases we're looking to run over Lisp.
Yep. Okay, so I think the architecture that I was hoping we could support is supported already. I can have 2 Dockers running, one say on my laptop, one on a desktop at home. I can take that laptop out on the road with me, and I can issue a get info on my laptop, but do a dash RPC connect equals, and then the 240 EID of my desktop at home, and it will communicate with it now via Lisp without having to make any further changes.
Exactly.
Absolutely correct.
That's exactly the architecture I think is going to be really, really useful to people.
Yeah, it's pretty fun, man.
Just to give you an example, Paul brought up a container on his system, and I brought up a container on my system. We were testing some Tritium. We both connected to the seed node with the 240 addresses and the FE addresses, and we each learned about each other through the seed node, and therefore we made a connection directly to each other. So the law of transitivity happened, right? We both connected to the seed, and the seed node told us about each other's EIDs, and then they connected. So A connected to B, C connected to B, and then A and C could connect to each other. Remember, we tested that.
It was a good moment.
Yeah, it was a good moment.
Yeah, wait till you see the new address manager we've been working on too. Jax, yeah, it's nice. We got a nice stochastic selection algorithm and a weighting algorithm so that when you get a list of peers, it'll have a more randomized, but more of a preference towards the higher ones too. So it's pretty cool. So that seeding is only getting much better, and it's a lot more reliable on picking up peers, which that's a really important part, peer discovery, because that really sets a precedence for all of your connections. And if you have unreliable connections, then your node's as good as, out of sync, and it's going to be hard to stay. So, the network code is really important, and that's why we've been spending a lot of time on these lower layers to get it right, because everything rides on top of it. So, it's just really, really important fundamentally to get these things functioning the way that they should, because that sets a precedence for everything that comes on top of it. If the bottom layer has any failures, then everything on top of it fails. So it's always good to get your low layers set as much as possible.
Awesome.
I guess, do we have any more questions? No more?
So we're going to work real hard in the next couple months so we can show you a Tritium demo probably in a few weeks or so, maybe after the holidays. Depends on how much functionality you want to show, but that should be the next thing we're going to try to demo for you guys. I am assuming people like the meetups. Please send us feedback if they're happening too often, if they're too technical, if you want more tutorial, if you want deeper. That's all useful feedback we could use.
Yep. And our kind of aim of these is just kind of let you guys know what's going on, show kind of where we're working, show how the tests are going, show the developmental progress. So, yeah, we appreciate the feedback. I guess that's a good point to conclude, unless there's any other questions or any other comments. No?
Okay.
All right.
Thanks for attending, folks.
All right. Thank you, guys.
Thanks very much.